The inner tracker detector is the part of the Atlas detector that we're most proud of in Oxford. That's because it was built here, it was constructed in our lab on Keble Road. The detector's purpose is to record the position of all the particles that are flying out from the collision point to the beams. We want to see the direction that they're going and to plot the track. This is done with many layers of silicon. It's a bit like a digital camera, but while the silicon chip inside your phone is detecting the photons of light that form the image, our silicon particle detector is recording the positions of any particles that hit the pixels. By looking at the path of the particle track inside a magnetic field, we can measure the particle's momentum. We know that light, fast-moving particles won't deflect it much at all, but the heavy, slower-moving particles are bent around into a curve. And by measuring the curvature of the track helps us to identify what type of particle it is. The raw data which comes out of the tracker detector is just a lot of points where we know a particle has passed. We then have an enormous join the dots exercise to tell which points belong to which particle track, and that needs some clever software, and it has to work fast, as when the experiment is running, there's new data coming in all the time. We're now working on the new upgraded detector that we installed in a few years' time. In the next upgrade of the Large Hadron Collider, the luminosity of the accelerator will be increased so much that we could see 200 proton-proton collisions happening all at the same time. And that means we need a high-resolution detector with smaller pixels, because we'll have so many particles flying out at the same time that if the pixels get too big, then it becomes impossible to see the separate tracks. Another challenge is to reduce the cost. If we can produce silicon detectors more cheaply, then we can afford more layers of silicon. So we then get a lot more data points for our money.